Today's problem, subarrays with at most k distinct integers, difficulty medium. You are given an array of positive integers and an integer k. Find the number of subarrays in array where the count of distinct integers is at most k. A subarray is a contiguous part of an array. All right. So they give some examples here. 1, 2, 3. Well, let's see. 1, 2, 2, 3. So what are the and k is 2. So at most 2 distinct elements. So what works? 1, 2, 2, 3, 1, 2, 2, 2, 2, 3, 1, 2, 2, 2, 2, 3. Yeah, that's not exactly the way that you would build them up, I think, with an algorithm, but okay. This one we'll look at as an example, I think, with the code. But the constraints are that the array size is between 1 and 2 times 10 to the 4th. 10 to the 4th. So 20,000 is the limit on the array size. The limit on k is also between 1 and 2 times 10 to the 4th. The numbers in the array are between 1 and 10 to the 9th. 1 billion. Complexities, linear. This is another sliding window algorithm. Actually, a lot of these, I don't know, it's like the problem of the day is sort of recurring themes with some variations. Some of it is find the longest subarray, some is find the number of sum arrays. So some of them are strings, some of them are exactly the requirements are different. So at most, this number of distinct characters, or exactly this number of distinct characters, or I can't remember, but all kind of variations on the theme, which makes, actually, if you're doing these every day, makes a lot of the code reusable. Obviously, you want to try to do these yourself before just watching a solution. But the expected complexity is ON, is linear. All of these are linear. You can do them with sliding windows, two pointers, topic tags, yeah, sliding window. So, okay. Let's look at this. Let's look at this one here. Get a pen. So what we're going to do, we're going to have two pointers, left and right, and we are going to use them to create sliding windows that have at most 2, in this case, distinct elements. All right, so let's start here. 1. Okay, so that works. That has fewer than 2 distinct elements, so that gives us a count of 1. Now, if we expand that, move the right pointer, now we have 1, 2. We want to add to the count the right minus left plus 1, which is 2. So we'll add 2 to that, and we'll get, now we have 3 subarrays. Add this, the 1. Now we still only have 2 distinct characters. How many new subarrays did we create by adding that? Well, we created this 1. We also created 1, 2. We also created 1, 2, 1. So that's 3. And again, you compute that right minus left plus 1. So we'll add 3 more. Now we have 6. Let's add this one. Okay. Still only 2. So we added 4 new subarrays. 1, 1, 1, 1, 1, 2, and 1, 1, 2, 1. So that brings us up to 10. Let's add this one, 3. Oh, now we got too many. We got too many numbers. We got to start deleting some until we only have 2 distinct characters. So this starts from the left pointer. So we'll take that out. Are we down to 2 yet? No, we still have 3. Let's take that out. Now we're down to 2. Okay, and we created 3 more. We created 3 more subarrays. 3, 3, 1, 3, 1, 1. So now we are up to 13. Add another one. We're still at 2 distinct elements, and we added 4 new subarrays. We are now up to 17. Add the 4. Ooh, we got too many distinct elements, so from the left, we'll start taking them off. We got to take that 1 off. It's not enough. We got to take this 1 off. Now we're back to 2 distinct elements, and we have 3 new subarrays, so we are up to 20. Okay, add this. 2. Too many distinct elements, so from the left, we'll start removing them until we get down to 2 distinct elements again. Now we've got 2 distinct elements, and we have 2 new subarrays. Add those, 22, and we'll add the last element here. We got too many distinct elements, and we have to remove 1. But it gives us 2 more distinct, two more subarrays, 1 and 1, 2. So we'll add those, I'm running out of space here, for a total of 24, which is the answer that we're looking for. All right, let me put the code in. We'll look at how the implementation works. Okay, let's initialize some variables. Count initially is 0. The left pointer is initially 0. Here is our map to keep track of what of integers and their counts. All right, now we have the right pointer. We're going to move the right pointer through the entire array. Can I scoot this over? Yeah, okay. So when we move it and encounter a new number, we're either going to add it to the map or we're going to increment the count in the map. If the map size has gone over k, well, let's do it this way. If the map size has not gone over k, then we don't go into this while loop. We just go down here and add to the count of arrays that we are creating, all right? But if by adding this new number we have gone over k distinct integers, then we have to work from the left and decrement the count of the left integer. Okay, if we decrement it all the way to 0, we will take it out of the map entirely, and then it doesn't count as part of our map size. So it reduces our number of distinct characters. Increment left, and we do this until we have shrunk the window back to 2 distinct characters, and that's it. So every time through, we will increment our count, possibly shrinking the window as needed. At the end, return the count. Let me move this over so we can see the results of submitting it. And here it goes. All right. That's it. Like the video, and what else? subscribe. If you subscribe, then you will get problems of the day in your inbox every weekday. You can also follow me on LinkedIn and keep track of them that way. So that's it for today, and we'll see you next time.